All right, 10.6, density. Students will be able to solve problems concerning real-world situations using their knowledge of volume, surface area, and density. Okay, so density. What is density? Well, it's just a ratio. It's just a ratio of mass to volume of any object. Therefore, the formula is simply density equals mass divided by volume. Now, we've talked about anytime you have a ratio equals a number, we can actually use this handy, what we've called the flux capacitor method, remember? So if you want to find density, you cover it up, and it must equal mass divided by volume. If you want to find mass, cover up mass, and it would equal density times volume. If you want to find volume, cover it up, and it would equal mass divided by density. So we're going to use this thing. The only thing that we have to remember is that the m for mass goes on top. Okay, so we got some basic practice problems here. First one just says calculate the density, and remember, units matter here. Okay, units are really important. So let's zoom in. It says a lead bar has a volume of 5.9 cubic meters and a mass of 64,900 kilograms. What's the density? Well, density equals mass over volume. The mass here is 64,000 kilograms, and the volume is 5.9 cubic meters. And so we just simply do 64,000 divided by 5.9. If you plug that in your calculator, you get 11,000. But it's really important that you include these units. So it's 11,000 kilograms per 1 cubic meter. That is the density. So density is always going to equal some number with a ratio of mass over volume. All right. Doesn't have to be kilograms over cubic meters. Pretty typically it is, but it's going to be some measurement of mass over some measurement of volume. So let's go to practice number 1, give you guys a try on this one. It says a piece of wood has a mass of 540 pounds and a volume of 12 cubic feet. So this one, your answer is going to be in pounds, because that's a measurement of mass, over volume is cubic feet. So your answer is going to be in that unit. Go ahead and give that one a shot, and then unpause when you're ready to continue. Okay, so we just plug it in. The mass is 540 pounds. The volume is 12 cubic feet. Multiply it out. We got 45 pounds over cubic feet. Now, if we knew our conversion factor from pounds to kilograms, we could multiply by that. And if we knew our conversion factor from cubic feet to cubic meters, we can multiply by that. But this one doesn't really ask us to do that. It just asks us to find the density ratio, and it's 45 pounds for 1 cubic feet. Okay, let's go on to another problem here. This one says, use the density formula to solve the following problem. So let's look at example 2 first. And the density formula, that's just this thing up here and here, right? That's all that really is. And we're going to use this one. So let's read it. It says a piece of metal has a density of 270 kilograms. So we know the density. And a volume of 200 cubic centimeters. This is important. They have cubic centimeters for measure of volume, and here my measure of volume is in meters. So we're going to have to do some conversion. Find the mass of the piece of metal. So we're actually going to be finding the mass. And mass is, if we cover that up, it's density times volume. So let's write our formula. Mass equals density times volume. So my density, I already know, is 270 kilograms. And that is over 1 cubic meter. Times by my volume, which is 200 cubic centimeters. So here's the interesting thing here, is we need to convert either cubic centimeters to meters or meters to cubic centimeters. So let's talk about that real quick. We do know that there are 100 centimeters in 1 meter. But we're not talking about just centimeters or just meters. We're talking about cubic meters and cubic centimeters. So what happens if we cube both of these things? Well, that's 100 cubed cubic centimeters equals 1 cubed is just 1 cubic meter. So let's add that into our ratio. I'm just going to extend it. And we can write 1 cubic meter up here, which we now know is equivalent to 100 to the 3rd power cubic centimeters here. I just wrote 100 to the 3rd power because this is going to be a big number. So I'm just going to do some math before I get some things to cancel out before I Actually multiply all this out and write out how big that number is. So now I can see I have a cubic meter down here, a cubic meter up here, I have a cubic centimeters up here, and a cubic centimeters up here, so now I'm left with just numbers and the unit of kilograms, which is good because they were asking me for mass anyway. So now I can just kind of solve it all out. I know that I have kilograms, and I know that I have 270 times 200 on top, and on the bottom I just have 100 to the third power. Pretty easy, we should be able to figure that out. Let's see, 270 times 200, that is 54,000, and 100 to the third power, this is a big number, it is 1,000,000, and that's in kilograms. So we can reduce this real quick. I'm just going to take the tens out, the hundreds out, the thousands out, and now I literally just have 54 divided by 1,000, which when you plug in your calculator is 0.054 kilograms. Perfect. Alright, so now I want you to try practice number 2. I want you to notice right away though that the mass they give you here is in grams and your density is in kilograms per cubic meter. So you're going to need to get from grams to kilograms somehow. Go ahead and give it a shot if you're not sure what to do. Don't worry, I'm going to work it out with you guys in just a second. Okay, so the overall math for this is actually pretty simple. We're just going to take the mass divided by the density. But the density is a ratio, so we can flip and multiply just like we do with any fraction. So I'm going to do 236.6 grams and times it by the reciprocal, where 1 cubic meter is on top and 1,000 kilograms on bottom. I then have this problem of it being in grams and kilograms, so I know that 1 kilogram is equivalent to 1,000 grams, and so I get 236.6 cubic meters over 1,000 squared. Now the problem with that is going to be a really small decimal answer. So to get to a number that's a little bit more significant, I thought I would go from cubic meters to cubic centimeters. Well, that's not that bad because we already know that there's 100 cubic centimeters in 1 meter cubed. So I just multiplied it by the meters. The cubic meters cancel out. And actually 100 cubed is the same thing as 1,000 squared. It's both 1,000,000, so these values actually cancel each other out. So now this equals 236.6 cubic centimeters rather than a really small decimal cubic meters. Let's go to the next page. Okay, there's other types of densities. We could also talk about the density of people per area. And so a kind of a way of thinking of that is that the density, if you're talking about the density of people, it would equal the number of people over an area. So if you're using the flux capacitor method that we talked about, the number of people would go on top, density over here, and then area here. All right, so let's go ahead and do this first problem together. It says example number 3. The U.S. covers an area of approximately 3.8 square miles, with 7.1% being covered by water. With a population of over 320 million people, what is the population density? So we're really looking for density still of U.S. in people to habitable square miles, so people to area basically. So they want the density, and they give us the units. We should have it in people to miles. That shouldn't be that big a deal because they give us square miles and they give us people. So first thing I notice is that they're telling us that 3.8 million square miles and 7.1% of it is covered by water. So my question then is, how much of it is covered by land? So couldn't we do 100% minus 7.1% to figure how much of it is covered by land? Well, if we do that, we get 92.9%. So it's not that we're dealing with 3.8 million square miles of land. We're dealing with 92.9% of that. So we need to multiply this 3.8 times 92.9. Or actually, we'll convert it to a decimal, so it's 0.929 times 3.8. And we know we're dealing with million square miles. Well, that equals, when we plug that into our calculator, that equals 3.5302 million square miles. All right, so there's our actual area. And now in order to calculate the density is the number of people over the area. Well, the number of people they give us, there's about 320 million people. And the area we now know is 3.5302 million square miles. Okay, million cancels out here. We got a million on top, million on bottom. So the real math that we're just going to do here is 320 divided by 3.5302. So let's just do that real quick. And we get approximately 90.65 person or people per every square mile. I'm just going to write miles squared. And so now we actually found the population density of the United States. It's pretty cool. You could look up some numbers on Google and see if you can find the population density of Vacaville or the population density of California or whatever it is that you wanted to look up. So I give you a practice problem here. Very similar situation. This is practice number 3. It says, from Indian Lakes put on a show at a venue in Sacramento last night. The rectangular floor of the venue had an area of 200 square meters. Okay, so you know the total area, and was packed shoulder to shoulder with fans. The band wants to know how many people were at last night's show. They estimate that on average each person takes up a circular space with a diameter of 0.8 meters. Since the floor was packed, they assume these circular spaces were tightly packed together in rows and columns. So let me explain that real quick. That means if everything's tightly packed together in rows and columns, then each person, even though it's like a circular space, would really only be taking up the equivalent of a square space. Okay? So we're not really going to find the area of a circle. We're going to find the area of a square. So if that square is 0.8 by 0.8, we could find the area of just one person. So the area of one person would just be 0.8 squared. And that's, of course, in meters squared. So that's simply 0.64 meters squared. So we actually found the area for one person. Okay. It asks us now to estimate how many people were at the From Indian Lakes show based on their assumptions. So we know the density. If you think about this, this is the area of one person. You could write this as the density of a single person would be one person per 0.64 square meters. And then that you could actually calculate. You could just do 1 divided by 0.64. And so now you actually come up with a number or a value for your density. It's 1.5625 people per every square meter. Okay, that's important because remember, if we go up here to the flux capacitor method, if we're looking for people, which is what this one says, estimate how many people, people equals density times area, density times area. So people equals density times area. Well, we know the density now, and we know the area of the whole venue too. It's right here. So we're just going to plug those things in. So density is 1.5625 people per square meter, and we could times that by 200 square meters. Square meters cancels out. 1.5625 times 200 is 312.5 people. Now, don't think that there was 0.5 people. Maybe there was a child there or something, but what we would say is that there's probably about 312 people, or even a better estimation is that there was about 300 people. That's a good way of estimating to the nearest hundredth, because that's all they really ask us to do. So pretty cool. There's about 300 people at their show. All right. That was fun, guys. What I want you guys to do for the summary, take a look through it. I just want you to kind of think about why would wood float on water, and why would most metals sink. So think about that, and just give me your best explanation. It's okay if you're wrong. Just give me a try.